So all they're asking for this problem is to rewrite equation in standard form, identify the center and the vertex, parts being B and C. So anyways, we did our A times C, or A times R2 coefficient, determine this was an ellipse, right? Yes, OK. So now we need to rewrite this in standard form. So therefore, I'm going to reorganize the x's. So I have 6x squared minus 24x plus 9y squared minus 54y equals negative 51. Because remember, the standard form is we have the x minus h plus y minus k squared, and then we have a squared and b squared down below. But we have those perfect squares. So what I need to do to create my perfect squares, I need to complete the square. So however, we need to complete the square for the x's and the y's, and then we have to make it equal to 1, not equal to 0. So first thing I need to do is I need to complete the square for my x's and my y's. So the first thing I do is factor out my coefficient of my squared terms, because you can't have coefficients of those terms, Elizabeth. You have to make sure you factor them out. So when I factor them out, I get x squared minus 4x plus 9 times y squared minus 6y equals a negative 51. Now I can do my b, yes? Because we're not trying to factor them out. We're trying to factor them, so we're just trying to factor out this coefficient. We're not trying to factor. We're trying to complete the square, meaning we want to create a perfect square trinomial. So it's actually, yes, if you were to ask, if I was to ask for factoring, that's what you do. But we're not interested in factoring this. We just want to factor out this term, so then we have a 1 in front of our quadratic. Because now, once you have a 1 in front of the quadratic, you take your b, divide it by 2, and square it, right? Yes? So now I'm going to use those terms, Marco, to now rewrite this as negative 4x plus 4 plus 9 times y squared minus 6y plus 9 equals a negative 51. All right? So I use these terms to now add it inside each parenthesis. But remember, since I'm adding 4, this 4 is being multiplied by a 6, though. So I need to, since I added 4 on this side, I need to add a 4 on this side, but I need to multiply it by 6. Since I added a 9 on this side, that's a negative 51. Since I added a 9 here, but it's being multiplied by 9 there, add those up. OK? So therefore, I have, this is 81 minus 51 will be 30. And then 4 times 6 would be 24, so it equals 54 again. Yes, my math is correct. 24, 54. So therefore, now I factor these to 6 times x minus 2 squared plus 9 times y minus 3 squared equals 54. But remember, the standard form was for us to set it equal to 1. So Ben, the next thing I do is I divide by 54 on all my sides. OK? Then I can simplify this. That reduces to 1 over 9. This reduces to 1 over 6. So therefore, my standard form is going to be x minus 2 squared over 9 plus y minus 3 squared over 6 equals 1. And now that I have it in that format, is it pretty easy to find the x and y axis? Or I'm sorry, the center? Yeah, the center in this case is going to be 2, 3. Our, remember, for an ellipse, our larger term is always our a. So we could say a squared equals 9. So therefore, a equals 3. Our b equals 6. So therefore, we don't need to figure out what b is. But they do want us to find the ellipse. So it is important for us to look at it. Our a is under the x. So does that mean we have a major axis vertically or horizontally or vertically? Horizontally. So therefore, if I have my center, my 2 vertices are going to be to the left and to the right, correct? So if I know my center is at 2, 3, and I want to find out the 2 vertices, I need to add and subtract a going left and right. So therefore, my vertices, remember, is going to be h plus or minus a, comma k. You're going to add and subtract the a to your h coordinate. So therefore, that's going to be 2 plus or minus 3, comma 3, which gives us negative 1, comma 3, and 5, comma 3. So there's going to be your two vertices. And then lastly, we need to figure out what our foci is. So our foci, we need to figure out what's a squared. So remember for an ellipse, the relationship is a squared equals b squared plus c squared. Well, a squared equals 9, b squared equals 6, plus c squared minus 6 minus 6. So 3 equals c squared. C equals the square root of 3. So to find the foci, it's going to be the exact same thing. Since this is a horizontal, remember, whatever your major axis is, that's where your vertices, your center, and your foci. So my foci is going to be h plus or minus c, comma k. Right? Because you're taking whatever your center is and you're going left or right. Now our c is a irrational number, but we can still add it in there. So I'll have 2 plus or minus the square root of 3, comma 3. And I'll just I'll do both of them. So there you go. And that would be your final answer. So now I have the center, the vertices, and the foci. And just notice, guys, since this is a horizontal, that's why I'm adding these to the h's. If it was a vertical, meaning the 9 would have been under the y, then I would have added my a and my c to the k. OK? And that's it. Voilà.